Think of a backend filter like a bouncer at a club. Before a request ever reaches your application code to be processed, it has to pass through this interception point where its credentials, headers, and paths are checked. This is the basic Java class signature for an AEM filter. To create one, the absolute minimum requirement is to implement the standard Java jix.servlet.filter interface. Inside this interface, the doFilter method is the exact location where your custom interception logic has to live. Without this interface implementation, the server lacks a hook to inject custom security or pre-processing rules into the request lifecycle. This architecture diagram maps how AEM routes traffic. Every incoming request to the backend enters through the Sling main servlet at the top left. From there, it is immediately handed over to the internal Sling request processor. The processor then delegates the request to a filter manager, maintaining 5 distinct filter chains: request, component, include, forward, and error. Following the orange arrows, the request flows entirely through the request scope chain first, before reaching the targeted component servlet. Placing a filter in the wrong chain can cause it to fire for every internal subrequest, which adds unnecessary overhead to every page load. We register the filter using the @SlingServletFilter annotation. This is the modern OSG standard for registering the service and defining its behavior. To protect system performance, we use the pattern and extensions properties to constrain the filter. This ensures it only runs on specific directories, like content, and against specific file types, like HTML or JSON. The methods property restricts execution even further, limiting the filter to specific HTTP actions like GET or HEAD requests. Finally, the scope property explicitly maps this code to one of the 5 filter chains we identified in the architecture diagram. Using these properties to tightly scope your filter prevents the engine from running this logic on every image rendition or client library, which keeps the request pipeline lean. A common point of failure occurs right after writing the interception logic inside doFilter. If you do not pass control to the next link in the filter chain, the request stops. When you omit this handoff, the pipeline hangs. The browser keeps loading indefinitely, and the user receives a completely blank page. Executing chain.doFilter, passing the request and response objects, allows the request to resume its journey to the server. Once your code is deployed, you can verify it as active using the AEM OSGI system console at the /status/filter path. The service.ranking value determines execution order. Lower numerical values ensure that your filter executes earlier in the chain than others. Checking this console confirms exactly where your filter sits in the priority list before it hits a production environment. Let's apply this. Your challenge is to upgrade a basic logging filter into an active authentication redirect for secure paths. You need to use a Sling HTTPS request to check if a path begins with a secure directory. If it does, issue a redirect to a login page without breaking the filter chain. Pause the video now, attempt to write out the logic, and press play when you are ready to see the solution. Handling redirects at this level ensures that security policies are enforced before the server spends any resources rendering the restricted page. In this solution, we first cast the standard servlet request to a Sling HTTPS request to gain access to AEM-specific resource paths. We then use an IF statement to check if the current request path starts with a designated secure directory. If that condition is met, we execute send redirect on the Sling HTTP server response object to reroute the user to the login page. The most critical step here is calling a standalone return statement immediately after issuing the redirect. Without this return, the code would continue to the chain.filter call on line 48, processing the restricted content and effectively bypassing the security check you just wrote. Terminating the method after a redirect is the standard pattern for ensuring the filter successfully blocks unauthorized access. Building a filter requires 4 main steps: implementing the interface, configuring the annotation, mapping the scope, and verifying the order in the OSGI console. Always call chain.filter to keep the request moving, unless you are explicitly terminating the request with a redirect or a block.